What is up, guys? Welcome to the Computer Information Highway for your Java programming tutorial number 35. And we're going to continue with our merge sort in this video. If you don't remember how the merge sort works, you can check out our episode or tutorial number 34, and it will explain how the merge sort works. This video is going to be the programming behind the merge sort, so I'm going to try to explain that as best as I can to you guys, and just hopefully you guys can keep up with it. So we're going to be making a main function. We can call this like merge sort because it's just going to be the main merge sort function that we're going to have. So we'll call it merge sort, and it's going to take a list. It's going to take an integer array, and we want to call it, let's just call it our unsorted array, sure. And it's also going to take a minimum and a maximum bound on the array because we're going to be splitting the function up in half. If we have the highest number end up being the index of 4 or 5, and we want it to be this one for the left side of our merge sort, we want the array to not take everything inside of it. So you'll see here in a minute what I'm talking about. We'll call it start, and we can make another one called end. And basically all this program is going to do, or all this section of the function is going to do, is split the array up into halves as many times as it can. And that's how we're going to start. So it's going to be int mid, because we want to calculate the midpoint first, is going to be equal to start plus end over 2. It's just a basic midpoint formula. And to split this up into two halves, we're going to be calling merge sort again, and this merge sort is going to call itself with new bounds on our array. And the bounds are going to be, so first we're going to pass in our array, and our bounds are going to be start up to mid. And this start up to mid is going to give us the first half of the list that we have. And every time we call it, it's going to keep cutting it and getting that first half. So then it will cut it in half again and maybe get this much, and then it'll cut it in half again and get this much, and then maybe it'll cut it one more time and get the 9. So that's how it's going to move up or that's how it's going to work with the left side of it. And we're also going to do the right side of it as well. So we want to take the unsorted array, we want to set it to mid plus 1, and we're doing the plus 1 because if we did mid again, we would be repeating the number over again, and I actually think the program would overflow because of it. And then we do end, because end is just going to be up to the end. So then we'll work from mid plus 1, which would be 2, up until the 5. And one of the things we should be paying attention to with our function is that since we're working with a recursive function, we want to make sure we put a base case in here that deals with like the minimum size that we're going to be working with. And the minimum size in this case is just going to be when it's 1. So the difference between start and end needs to be 1. Oops. Or we could just say that start always needs to be less than end. So if start is less than end, it's going to do everything in here. So this will go up until the start index increases all the way up until it's the same number of, or it has the same number as the end. So in the situation where it breaks down into two sets of one number with L1A and L1B, say, the start and the end has no difference in it. It's exactly 1, so the situation would not execute. It would never make it into this set of code. So that's how we're going to determine our base case. And that is going to be really the hardest part of the recursion. The rest of it is actually just going to be looping through each of the lists, and it's just going to be sorting them. You'll see. So because merge sort is going to happen first, This is how we know, or the merge sort at start to mid is happening first. This is how we know it was just going to be going down the left side, and this is how you know it's going down the right side, what I was saying in the video before. Um, so it's going to completely move down through the left side first before it ever starts the right side. And the reason for that is because whenever it gets to this line 13 right here, it calls merge sort again and doesn't make it to this code until after it makes it into merge sort uh, again, or rather, it will keep going inside of it until this conditional statement does not execute, and then it will work on the right side. Um, so we really just have one more function we're going to work with, and it's just going to be like a merging function. So we're going to have, so if we have two lists, and we know the index of our starting position, and we know the index of our ending position, and we know the middle position, we can just merge them together until the whole array sorts itself out. So I'm going to show you what this merge function does. And this merge function is going to take 3 arguments. The first is just, once again, just going to be our array. Let's call it unsorted again. The minimum, or the start value that we're going to be putting in, is just going to be start. We're just going to be putting in mid, and we're just going to be putting in end. So I said 3, but it's actually 4 arguments that we have to put in. So let's go ahead and create this function. Right? And then with this function, we need to work with what we're doing with the left side of our function, what we're doing with the right side of our function, and then merge it all together. So if you remember in the code here, this was our left side and this was our right side here, and we had to break this up into smaller arrays. Basically what we're going to be checking is whenever we get to the situation where we're down to single numbers or even multiple numbers in a sorted list, like in these situations here, we want to make sure we iterate through the entire left column and the entire right column and check to see that the left, or the left and the right column, yeah, the left and the right column, and make sure that the left is less than the right, and just put the smaller number in first. So we can do that pretty simply. So let's just work with our left side first, and the left side, and I'm going to comment this out so you guys will have the code for yourselves later. So we can just say left side, right side, merge, because this is going to be the main 3 things that happen inside of this function. We're going to create our new left side of the list, and the reason we need to create, or we're going to be creating new arrays for each of these, and the reason we need to create new ones is because we need to move the positions around of the list, but we're basically just going to be overwriting everything in our original list by breaking up the list into smaller lists. So if we have our left list, and I'm just going to call this, so we need to create an array, and we want this to be called, let's call this left list. And we want this to be the size of, since this is going to be the left instance of our list, this is going to be mid minus start, and then it's going to be adding +2. The reason we add the +2 is because the mid and the start include the location of the last index, or the last index -1. So we need to make sure we include both of the additional ones that we have on there. And then we're just going to be iterating through our list. We're going to be iterating up to start. I'm sorry, we're going to be starting from start and iterating up to mid +1, so that it includes the middle position. and then we are just going to populate our list. We're going to say our list of, this is going to be our list of I minus start, so that it always starts at 0. Yeah. So if our start position is 0, it's not going to subtract any out, and it's just going to start from the position at 0. But if our start position is, say, mid plus 1, we want it to make sure it doesn't go out of bounds of our lists. So that becomes I minus start, and we want to set that to unsorted of I, because we're going to be using the position in I, and we want to make sure that this list doesn't go out of bounds even though we're using a smaller array size for it. So this is going to stay inside of the bounds of our list, because our sorted list is going to be split up into those sizes. I don't know if that makes sense, but I'm hoping it does. So now we're going to work on the, oh, sorry, there's one more thing we need to do. So we need to set our list. So we need to set mid minus start plus 1. So this is the next index after mid minus start. And we want to set this to integer max value. Oops. And the reason we set it to integer.max value is so that it's never less than the number that we're looking at. It's always just going to be maxed out. So that it won't ever like perform a swap on it, because we don't want it to swap unnecessarily. So now we can pretty much do the same thing that we did here. We're going to copy it and paste it, and we're going to make this our right side. So we switch that to R, R, and R. And now our bounds are going to change as well. So rather than mid minus start plus 2, we're going to be doing end minus mid plus 1. And the reason we're doing plus 1 here instead of the plus 2 is when we do up to mid, so when we're doing up to mid the first time, it's going to be including it. And since now we're not including it for the right side, where is it? Yeah. Since this is the left side, we're including the middle position. And in the right side, we're not including the middle position. So it's not including that extra index at mid, which helps us keep it inside of the bounds of our list. So it becomes n minus mid plus 1. And then in our loop, it's going to start at mid plus 1, because once again, it's not going to include the middle position. It was already taken care of in the left side. And we're going to continue up to n plus 1. And that's just so we include the last position, because our n position right now is going to be set to the 5 that we have, and we want it to also include the 5. And then just like with the I minus start, we're going to be doing I minus mid and do a minus 1 to make up for the end. And it's just going to be equal to our unsorted of I, because our list is still going through the original unsorted list. We haven't changed the list itself. And then for our last bounds, we need to do end minus mid. And that takes care of both the left and the right side of our two lists. Now this will work in the case where the list is of size 1. It will also work with the case where the list is of size like 50 or whatever. Because it's all dynamically based, it's all based on the size of the numbers that we put in, the size of the array that we have, and it's just cutting it in half and working with 2 separate halves on each one. So the last part is to just merge these 2 sorted lists that we have, and they're not sorted right away, but in the case where it goes all the way down to where the list size is 1, we assume that they're going to be sorted at list size 1. So we go ahead and perform our merge on our unsorted list. So we're going to create 2 dummy variables. We're going to create I and j. And this is going to be to keep track of our list positions that we are in for our left and our right side. And then we're going to be using a third one just to go up to the length of our whole list, because we only actually need to you'll see. So int k equals start, because we're going to start at our starting position. K is less than end, plus 1, because we're going to go all the way up to our ending position and include our ending position. And then we're going to do k plus plus. So this will do everything in the array that we have. And I should probably use brackets because it's not going to just be one line. And for our condition in here, we're basically just going to be checking if our left list is smaller than our right list. So if L list of I is less than R list of J, so this is the case where the left side of our list at this position is less than the right side of our list at this position. And when it is, we're basically just going to be changing our unsorted value again. So we're just going to say our unsorted value of k is going to be equal to our left list of I plus plus. I'm just doing the I plus plus, so I don't need extra brackets. You can call this I plus plus even inside of brackets because the plus plus takes place after the integer, which means it will process whatever the value of the integer is before it will add an additional count to it. So this will only take L list of I first, and then after that, after it uses that data, will it increment it by 1. And then with our else statement, we're just going to be doing unsorted of k equals R list of j plus plus. And the reason we're using the i's and the j's in here is so that it will increase through our list over here. So we had our 2 sorted lists, and if the I gets chosen, or following our example that we're using in our merge sort here, since we have 2, 9, 1, and 15, we went through the first, we checked the first one starting at 0, so SL1 of 0 is going to be 2, and since 2 is less than our SL2 of also 0, which is 1, 1 is going to be the first number that we put in, and then we're checking the next value. Since our 1 was put in, we set our unsorted k equal to our R list and then incremented it. So the j is going to move up 1 position. So then it checks the 2 to the 15. The 2 is less than the 15, which is why we put it in, and then that's what increments our I position. And then it repeats the same thing for the last one. Since our 9 was less than 15, it puts the 9 and then 15, which will increment these, but since we're not going to go outside of those bounds, you don't ever need to worry about it going farther than the size of the list that we have. So I think we can just about test this. If we come up with any problems, I'll go ahead and fix them. So let's just do int I in unsorted. This is a quick for loop. This is how you just iterate through every value inside of an array. And I'm just going to printf to the screen, which is our print format. I don't know if I went over print format before, but we can just do we can just do I. And now we would just want to call our merge function. So we're going to be merging our it's going to be our merge sort function. And we're going to be taking our unsorted array, our start index, which is going to be 0, and our end index, which is going to be unsorted length minus 1, I believe. So let's go ahead and run this and see what happens. So actually, let me copy and paste this first. I'm going to do it twice. I'm going to do it once before and once afterwards, so we can see what happens to the array. Alright, boom. Alright, it looks pretty good right now. So we started off with our 9, 15, 1, 65, 4, blah, blah, blah. And then after we move through our merge sort, we go 1, 2, 5, 5. Since it's the same number, technically the situation counted to where it took the j situation. or it took the right list instead of the left list because they were the same. Um, so it went 1, 2, 5, 5, and it didn't matter if it would have put it on the right or the left, it would have merged the same either way. 9, 13, 15, 18, 65, 91. Yep, everything looks like it's in order. So this was the merge sort that I went through, and I hope you guys find this useful. I'm going to do probably a couple more sorts, or yeah, I'll probably do a couple more sorts over the next couple days, just because different sorts are nice to know, and you can pick your favorite one. Uh, and after I finish them all up, I'll tell you guys, I think, which one I like the most. But this is just the first one I wanted to do. So I will see you guys in the next program that we make. If you like this video, go ahead and give it a thumbs up. If you didn't like it, whatever, give it a thumbs up or a thumbs down. Hey, if you give it a thumbs up and you dislike it, that's pretty cool too. Uh, if you really like my channel, go ahead and subscribe, yada yada yada. I'll see you guys next time.